All right, so let's take a look here at problem number 11. They give us a trig equation. It's cosine. There may be infinitely many solutions to that, but we only want the solutions that are between 0 and 360. So let's get this cosine by itself. Let's subtract 5 from each side and then divide by -8. So in 2 steps, we'll have this by itself. If we subtract 5, we've got -2. If we divide that by -8, we get 1/4. Now, if I look on my unit circle, I don't have an x-coordinate of 1/4. So I'm going to have to use my calculator. And I would expect cosine to have a ratio of 1/4 at some point in quadrant 1 and at some point in quadrant 4. So the calculator, though, when I go to use it, it's going to treat it like a function, and it's not a relation. It's going to restrict its search to just the upper half of the unit circle. So it's only going to find that quadrant 1 angle. So if we go to the calculator, make sure that we're in degrees, and we are. It says to round it to the nearest tenth, so let's let the calculator do the work for us. And let's go inverse cosine of 1/4. So that 75.5 degrees, that's a quadrant 1 angle. So we have that x plus 180 is equal to, where'd my calculator go? 75.5. Now, that or any angle that is coterminal to that. Yeah, so there's one equation that I need. Now let's come over for this quadrant 4 angle and get an expression for it. So let's go back to my calculator here. 75.5 is in quadrant 1. I can use that as a reference angle, and I can take 360, which is 1 revolution minus that reference angle, and that'll get me my quadrant 4 angle that I'm looking for. So 284.5. And any angle that is coterminal to it. Now, to get x here, let's subtract 180. So if I have 75.5 minus 180, well, that's a negative 104.5. Let's come over and subtract 180 from this other equation over here. 284.5 minus 180. 104.5. So that describes infinitely many solutions. I'm just getting to that point again and again and again through coterminal angles, and then back to that point through coterminal angles. Now, we only want the angles that are between 0 and 360. So let's shorten this up and construct a table and see if our table can help us. So the solutions from this equation, I'm going to call that 1, and the solutions from that one, 2. All right, so if we let n be 0, well, we've got a problem with this first equation because we want our angle measures to be bigger than 0. So this 104.5 might be a solution to the equation, or it is, unless we check it and find that we made a mistake. It's a solution to the equation, but it's not between 0 and 360. But this other guy, if we have n be 0 here, this 104 is between 0 and 360. So that's going to be on our solution set. If we let n be 1, let's see what we have here. We've got negative 104.5 plus 360. 255.5. And if we let n be 1 here, we're obviously bigger than 360, and we want to be under that. So this one is too big. So the two values that we have that are between 0 and 360 is the 104.5 and the 255.5. Let's check those, see if they work in the equation. We've got 5 minus 8 times the cosine of 104.5 plus 180. And let's check that we're in degrees. Yep. And this should be 3 or real close to 3. So there it is, 3. All right, so let's change our 104.5 to 255.5 and make sure $255.5, and hey, that's also 3. So both of them check. Both of them are in the range that we want. So there's our solution. Let's highlight it. I have to turn on my heat. I'm sitting here freezing. I'm shaking as I'm doing this. So those are in our solution set. Those, although there's infinitely many values that satisfy this equation, it's only those two that are between 0 and 360. So I hope that helps, and I'll talk to you later. Bye.